Welcome back to P4. Today we're going to look at integration by substitution. What this basically does is change the variable in my integration to something that then is easier to integrate. Now, the majority of the time when this does happen, or you get a question on this in an exam, they will usually give you the substitution. However, there are a couple of questions where you could use this method or an alternative method to solve it. In those cases, it wouldn't give you the substitution. But it doesn't mean that you can't use it. Now, the easiest way to kind of understand this is simply for me to show you. So that's what I'll do now. So in this example, we need to find this integration using this substitution. So I'm going to start, and I always start the same way. It just means that I can move things around my sheet, but using that I means it's very clear to the examiner what I'm doing with the integration. So u equals x minus 3, and we always need to differentiate this because we're going to need to replace this dx. So dx by du, in this case, is just going to be 1. So du equals dx. Nice and easy. And then from this, I am going to have to replace this x. So I want to rearrange. So this is going to be x equals u plus 3. Now I have everything I need to substitute in. So my I is going to be, now x is going to be replaced by u plus 3. U plus 3, and I've got square root, and then the x minus 3 is u. So square root of u, and then dx, you can see, is equal to du. So we've actually got u plus 3, I'll take extra steps, times u to the power of half du. So multiplying or expanding that bracket, I would get u to the 3 over 2 plus 3u to the half du. Now we can go ahead and integrate. So add 1 to the power, divide by the power. Add 1 to the power, divide by my power. And don't forget my plus c. Now I'll go over here. You can see I'm using that I now just to show where I'm carrying on and know it's the integration. So we get 2/5 u to the 5 over 2 plus, now we're going to get 2u to the 3 over 2 plus c. Now, at this kind of point, if I had limits, I would be able to substitute my converted limits in and get a numerical answer. But I don't have limits, so I need to convert it back in terms of x. So this means that I get 2/5, and u was x minus 3. Plus 2x minus 3 to the power 3 over 2 plus c. And there I am, done. Hopefully that's not too difficult to follow. Let's have a look at the next example. I'm going to do the same questions. We should get the same answer, but I'm going to use a slightly amended substitution. Actually, before I jump into that, I've just noticed I actually haven't fully simplified this because we've got two brackets that are the same. So we can actually take part of this bracket out. So we can actually simplify this much further. Now, it's probably easier to simplify it from here. So I'll do that. I'll do it in a different color and I'll show you what I mean. So if I just go back to this step, and what I'm going to do is I'm actually going to ignore the plus c for now. I'm just going to focus on this part. So if I look at this, I can quite clearly take a 2 out of both, and I'm going to take a 5 out of both. So I'll do it in 2 steps. So if I take my constant out, the 2/5, this is what I'm going to get. Now I want to take out the algebraic part, so coming into both is u to the 3/2. That'll leave me with u plus 5 in my brackets. Now, if I substitute back in my u, which we know is x minus 3, we get x minus 3 plus 5 in that bracket. So now we can see we've got 2/5 x plus 2 x minus 3 to the 3/2. And then of course bring my plus c down here, plus c. And this is a far nicer way to leave my answer, far simpler. So in this one, same question, but I've got a u squared as my substitution. So because we got a square root, then sometimes it's nice to use the u squared as a substitution instead of just u. So let's have a look in this particular question if it's helpful or not. So starting the same way as before, and just writing that out. And we know that u squared equals x minus 3. Differentiating with respect to x gives me 2u du by dx equals 1. So 2u du equals dx. Brilliant. Now looking at my u squared equals x minus 3, I need to get that as x equals u squared plus 3. Now I've got all my bases covered, I can substitute in. So instead of x, I've got u squared plus 3. And then instead of my square root 3, so this is going to be square root of u squared. I would normally just jump straight in with the u, but I'm going to do it in steps. And then we've also got the 2u du, which replaces my dx. So here we now got an integration of u times u squared minus 3, plus 3, times 2u du. So let's expand everything. So we've got, actually let's put these two together. So we've got 2u squared, then u squared plus 3 du. And expanding my brackets fully, we get 2u to the power 4 plus 6u squared du. Now let's go ahead and integrate this. That's 2u to the 5/5 plus 6u cubed over 3. And of course I can simplify the 3 into that 6, because what we've got is we've actually got this u squared coming in here instead of just a u. So what we end up with here is 2/5 x minus 3 to the power 5/2 plus 2x minus 3 to the power 3/2 plus c, which is 2/5 x plus 2 multiplied by x minus 3 to the 3/2. I'm just going to pop that in there from, I've already shown you how to get to it from the last one. So this is the same as the last one, therefore this step will be the same as the last example. But which one is easier? I think it comes down to personal preference, and sometimes depends on the question themselves. So yeah, I would recommend you try, both ways a few times as you do questions and see which way you prefer. Because if it doesn't give you the substitution, you might want to choose either between u or u squared when you've got a square root within your integration. Now, what happens when we have limits? If we've got limits, we don't have to worry about changing it back in terms of x. We'll be able to keep everything in terms of u, change our limits in terms of u, and solve. Using the substitution u squared equals 4x plus 1, it does say or otherwise. So it does mean I can do it another way, which I can do, but this is probably going to be the easiest way. Find the exact value of this. So let's start with just letting I equal my integration. That's what I like to do. I for integration, and let's put this one down. It just means that as I start to change this around, I can still just use that I equals. Okay, now I want to substitute in u squared. So if I look at my integration here, if I substitute the u squared would be replacing 4x plus 1, so I get the square root of u squared, which is just u, but I will put it in on the bottom as full. Now, the 8x is a little bit of an issue. You might initially think, right, I'm going to have to take the square root of this, but we also need to deal with this dx. So before we start rearranging this for this 8x, let's deal with the dx first. So I've got u squared equals 4x plus 1, and what I want to do is differentiate this. So I'm differentiating with respect to x, so I'm going to get 2u du by dx on the left, and then I'm going to get 4 on the right. So I get 2u du equals 4 dx. And that hasn't helped me out with the 8x, so now let's start with the u squared equals 4x plus 1. U squared minus 1 equals 4x. So 8x is going to be double that, so 2u squared minus 2. Now I've got everything I need to substitute in. So I can replace the 8x with 2u squared minus 2. And I can replace the dx with, which actually I didn't do here, so we've got half u du. So the dx is going to be replaced with a half times u du. Now I've pretty much done everything I need to. The only thing that I've got left to do, and it is one of the most common mistakes, is deal with my limits. So when x equals 20, I need to find out what u is. So let's go over here, and I'll do this one in green just so that you can see it. So u squared will equal 4 lots of 20 plus 1. So 4 20s are 80, so this is going to be 81. So u will be 9. And then we're looking at u squared equals 4 lots of 6 plus 1. So that's going to give me 25. So u is going to be 5. So my new limits are between 9 and 5. So let's carry on with this. So we're between 9 and 5. And let's deal with the top. We're going to multiply everything by a half u. So 2u squared minus a half u is going to be 1u cubed, and minus 2 times a half u is just going to be u, and that's over u du. Now, you should be able to see that we can also sort this out a little bit because we're dividing by just u. So this gives me u squared minus 1 du. Nice, easy integration. So I'm just going to move over a little bit. So let's integrate this. U cubed over 3 minus u, and this is between 9 and 5. Substitute these in. 9 cubed over 3 minus 9. Minus, and then we've got 5 cubed over 3 minus 5. And that leaves me with 592 over 3, or 197.3 to 1 decimal place. And don't forget, you can put the original into the calculator and check your answer there. So this is me using substitution and with limits. You'll notice that with limits, it's nice and easy. As long as I change my limits to make them in terms of u, then I don't have to worry about changing my integration once I've completed it, changing this expression back in terms of x. Now, it's very tempting to leave it here, but there is actually a common factor because these brackets are the same. So what I'm actually going to do is I'm going to show you how to simplify this further, but I'm going to start with this step as it's easier from here. So what we're going to do is we're going to factorize. So I'm going to take u to the 3 over 2 out of both. That's the highest power that goes into both. And I'm going to take out the 10th. That'll mean I get u in my brackets, because u to the 3 over 2 times by u is u to the 5 over 2 minus, and obviously I'll have 1 on the top here for the u to the 3 over 2, but I actually went over 2, so this is going to become minus 5. And that's simply because minus 5 times a 10th is going to give me that 2 on the bottom, the half. And then the 3 over 2, obviously, we've already taken out, so it's just 1. Now, if I substitute back in, so if you remember, u equals 3 plus 2x. So we get 3 plus 2x to the power 3 over 2 over 10. 3 plus 2x minus 5 in the brackets. And then it's just a little bit more simplifying. So that gives me 2x minus 2. Oh, factor of 2 I can take out to there. So a factor of 2 would come out. So we get 2 over 10 essentially. 3 plus 2x to the 3 over 2x minus 1. So fully simplified, 1/5 x minus 1, 3 plus 2x to the 3 over 2. Hopefully you were able to follow that okay. This is a more challenging one, but it is nice to be able to fully simplify it. So, quite challenging today. I've tried to pick ones that are maybe a little bit harder than what you might always see. Hopefully it was okay. If you enjoyed the video, give us a thumbs up. If you haven't subscribed yet, hit the subscribe. And any questions or anything you want to say, just hit the comments down below. See you next time.